Hey everyone, in this video I'm going to go over multiplying radicals. So what you're going to do is multiply the inside of the radicals first and simplify. So the first thing I'm going to do with example 1 is I'm going to multiply the inside. So I'll get 5 times 10, which is radical 50. After that, I'm going to try to reduce 50 with something that's perfect. So the square root of 50, inside of 50 is 25 and 2. So the square root of 25 is 5, and the square root of 2 is just square root of 2 because you can't reduce it. So this is the final answer. For the next one, if you notice, there's a negative 4 and a negative sign outside. So what I'm going to do first is I'm going to multiply the negative 4 and the negative 1 that's technically here to get me a positive 4. Then I'm going to multiply the insides to get me a radical 15 times radical 3, which is radical 45. So now I got to think, can I reduce the square root of 45? And I can, because inside of 45 is 9 and 5. 9 being the perfect piece. So the square root of 9 is 3, and the square root of 5 will just stay the same because it's not perfect. I will bring down this 4 and multiply the 4 times the 3, which gives me a final answer of 12 radical 5. In the next example, if you notice, there are pieces outside of the parentheses. What we're going to do first, most people think to reduce the inside, but you cannot because they're different radicals. If you can simplify somehow, you can go ahead and do the insides first, but because this case I cannot, I'm going to go ahead and distribute what's outside. So when I distribute this, I'm going to multiply the radicals times the radicals. Really, there's a 1 in front of here, so my first step is to do 1 times negative 5, which is negative 5. And then I multiply radical 3 times radical 10 to get a radical 30. Plus 1 radical 3 and radical 6 gets you a square root of 18. So now I'm going to try to simplify. 30 is a little tricky because the factors of 30 are 6 and 5, which neither of them are perfect, 3 and 10, which also aren't perfect, and 1 and 30. And 2 and 15, which none of these numbers are perfect. So this is actually simplified, this piece of the expression. It's done. But I can reduce 18. The square root of 18 will break up into the square root of 9 and the square root of 2, allowing me to make the square root of 9 a 3, radical 2. You could rearrange this so that the negative is coming second. Usually mathematicians try to do that. But either way, it's written correctly. The next example, I'm going to do the same thing. I will distribute the outside into the inside. With this one, I'm going to multiply the numbers first. So negative 3 times negative 2 is a positive 6, because negative times negative. And 15 times 3 is the square root of 45. Okay, and then I'm also going to multiply negative 2 times positive 3, which gives me a negative 6. And then that becomes the square root of 75. I'm now going to reduce each radical to see if I can simplify it at any point. 45 does break up into 9 and 5 because 9 is perfect. This is a good idea. Square root of 9 becomes a 3, radical 5. Minus 6. The square root of 75 will break up into 25 and 3. 25 being the perfect piece of 75. Allowing me to take the square root of 25, which will be 5, radical 3. Now I'm just going to simplify each term and see if I can combine them. 6 times 3 is 18. Radical 5. And 6 times 5 is minus 30, radical 3. Because the radicals are not the same in this case, like I have a radical 5 and a radical 3, I can no longer continue, and this is my final answer. In the next question, if you notice, both of these are binomials. So what you can do is either do FOIL or box method. I will do box method because most of you prefer. So I'm going to put the square root of 5 minus the square root of 3 on the top, and the square root of 5 plus the square root of 3 on the side. The square root of 5 times the square root of 5 is the square root of 25. And the square root of 5 times negative square root of 3 is a negative square root of 15. And then the square root of 3 times the square root of positive 5 is a positive square root of 15. And then a negative times a positive is a negative, and this becomes the square root of 9. These will cancel because they're opposite signs. So I'm left with the square root of 25 minus the square root of 9. I can reduce 25 into 5, and 9 becomes 3, which gives me a final answer of just 2. Okay, so now what I'm going to do is I'm going to do the next one. And with this one, I'm also going to do the box method. So I'm going to put -2, -3 radical 5 on the top, and then 5 minus radical 5 on the side. Notice 3 radical 5 is one piece. I know that they look separate, but they are still one piece, so I only have 4 pieces in my box. 5 times -2 is a -10. 5 times -3 is -15, and I'm just going to keep the radical 5 here because there's no radical on the left side to multiply by it, so it just stays the same. -2 times a negative radical 5 is a positive 2 radical 5. And then negative radical 5 times a -3 radical 5 becomes a positive 3 radical 25. Unlike the last one, I do have things to combine instead of cancel out. These will combine to a -13 radical 5. And then 3 radical 25 will become 3 times 5 because the square root of 25 is 5. Okay, this will become -10 minus 13 radical 5, and then plus 15. I will add these together because they are like terms. -10 plus 15 is a positive 5 minus 13 radical 5. I hope this video helped. I'll see you guys soon.